Good morning, children. Let me continue with the chapter periodic table. Today, I would like to explain about a point called the periodicity. We call this table as periodic table because the period word has got some meaning. Just see here. A repetition of properties after a certain interval is called a periodicity. You need to by heart this definition which I have underlined already. The repetition of properties after a certain interval is called a periodicity. After a fixed interval, property will be repeating. And why it is happening in this periodic table, just I will tell you. Just look at here. In this diagram, you will see the electronic configuration of lithium as 2,1, sodium 281, potassium 2881. What is the similarity in these three? All these three elements, including hydrogen, all these four elements are having one valence electron. That means one electron in the last shell. If the valence electrons are same, the chemical property will be also same. So, in a periodic table, suppose if you move from left to right in a periodic table, the first lithium has got one valence electron, but when you move forward, you will not find that one valence electron nowhere. And for that, you have to come down just below sodium here. So the properties are repeated after a fixed interval because of the same number of valence electron. If you take here fluorine has got electronic configuration 287, and in this period nowhere you will find 7 valence electrons. And just below fluorine, it is chlorine 287. Chlorine is also having 7 valence electron, and nowhere in this period you will find 7 valence electron. So fluorine and chlorine both are having same property because of their same number of valence electrons. So when you move across a period, valence electron always changes, the property will be also changes. So when the property reappears when elements are having same number of valence electron. I think it is somewhat clear for you. Just come back. Periodicity I already defined. It's a repetition of property after a certain interval. Just to continue reading. If elements are arranged in the increasing order of their atomic number in the periodic table, then element repeat its properties after definite interval. This repetition of properties is known as periodicity. I've just gave you an explanation. That's all. You mainly by heart that first line for examination point of view. Just for an example, again I placed here something. All the first group elements starting with the lithium to francium, all those elements, if you carefully watch, you will find one valence electron in all the elements. That is why they are having same property. Remember that. Then just below that I have written the cause of periodicity. What is the cause of periodicity? Very clear. The cause of periodicity is the same number of valence electrons. Only you have to remember this much. Cause of periodicity is the same number of valence electrons. Then just the last line I write something there. In a group, properties remain same. Just see, property remains same because again valence electrons are same. That is why same group. Element shows same properties. Okay, that's all about periodicity. So because of this repetition of property in this table, we call this table as a periodic table. Now next we will discuss about the trends in a periodic table across a period. What is the trend? We will just see what are the how it varies. That means all these properties, sometimes it may increase, sometimes it may decrease, sometimes it remains same. So we will discuss one by one. The first point is atomic number. Atomic number. Just see here atomic number. The atomic number of sodium is 11, magnesium 12, 13, 14, 15, 16, 17 and 18. Across a period, you see that atomic number increases one by one. That is a trend of atomic number across a period. While you move across a period, atomic number increases one by one. That's all. Then second point about shells. If you take this, this is the third period I placed in front of you. all these elements are having 3 shells. You take any period, the number of shell always remains same. Whether you take it second period, if you take second period, all the elements will have 2 periods. If you go for a fourth period, all elements will have 4 shells. Okay, so shell decides the period. Remember that. Then the third point is valence electron. We have discussed so many times about valence electrons. Valence electron means number of electrons present in the last shell. With red color you will be able to see the valence electron. Sodium has got 1 valence electron, magnesium 2, aluminum 3 valence electron, silicon 4 valence electron, and argon has got 8 valence electrons. So that means across a period, valence electron again increases 1 by 1. Okay, so atomic number increases 1 by 1, valence electron also increases 1 by 1, and the shell's number remains same. Keep all these things in your mind. Okay, these points are important for the examination point of view. Next, let me move to the next point called atomic size. Atomic size or atomic radius. See, these topics I already explained through the online teaching, but on that day only half of the students of class 10th attended the class. That is why I am sending this video again. Okay, then look at this next point, atomic size or atomic radius. The atomic size or atomic radius is the distance between the nucleus and the outermost shell. Distance between the nucleus, that means the center of the atom, and to the outermost shell. The distance between the, just here is a diagram, you'll be able to see the distance between the center to the outermost shell is called atomic radius. Now we have to see in this point across a period what happens to the atomic size, and theory says that in this blue letter you will be able to see in a period atomic size decreases from left to right. While you move across a period, atomic size decreases. Now we have to discuss in detail how the atomic size decreases, and the reason you should know very clearly, so you need to focus on this video. Okay, just look at this left side. I've just placed a diagram here. Just look at here. While you move across a period, the picture will clearly tell you atomic size gradually decreases. Keep this diagram in your mind. While you move across a period, atomic size decreases, and what I am discussing here is only up to 7th group. This concept will not be applicable for noble gas, and noble gas has got an entirely different concept. So what I am discussing here is applicable, it's applied only up to 7th group, remember that. Then now how the atomic size decreases, now we are going to discuss that. Okay, listen carefully. See, if we take the example of sodium, atomic number 11, magnesium 12, while you move across a period, atomic number increases 1 by 1. That means number of protons in the nucleus, increases 1 by 1. एक एक करके protons का number बढ़ता जा रहा है. Proton is situated in the nucleus. As you all know, proton is situated in the nucleus, that means center of the atom. So आगे बढ़ने पे एटॉमिक नंबर बढ़ने की वजह से प्रोटॉन्स का नंबर भी बढ़ रहा है. प्रोटॉन्स का नंबर बढ़ने से न्यूक्लियस का चार्ज बढ़ रहा है, and because of that increase in nuclear charge, with the red color I have placed here, an increase in nuclear charge decreases the size of the atom. How it decreases the size of the atom, let me tell you that also. Because of that increase in nuclear charge, what happens is the nucleus will be pulling the outermost shell strongly inward. न्यूक्लियस का ताकत बढ़ने से न्यूक्लियस आखिरी शेल को अंदर की तरफ खींचने लगता है. Because of that pulling, the size of the atom gradually decreases. Let me explain to you once again. In examination, they'll ask you about the trend of atomic size across a period. You will say very clearly atomic size decreases across a period, and in case if they ask you the reason, you will clearly say increase in nuclear charge is the reason behind it. And why that nuclear charge is increasing? Because of increase in protons. because of increase in number of protons, positive charge increases, nuclear charge increases. As a result, the last shell will be pulled very strongly inward, and hence the atomic size decreases. I think it is somewhat clear for you. Children, listen to the video audio a few times and understand. In case if things are not clear, when we come for an online class, you may ask the doubts. Okay, thank you.